So in lesson 8.5, we're going to be factoring these trinomials and kind of going in reverse from the last couple sections, similar to what we did early in the chapter with multiplying and factoring binomials. So to introduce this concept, let's imagine that we have a rectangular solar panel and they give us the area of that, x squared plus 7x plus 12, and they give us the height is x plus 3, but we don't really know the base yet. So area would be base times height, but since we only know one of them, we can only set this up so far as the area given, x squared plus 7x plus 12, equals something times that height, which is x plus 3. So that's why we need to know how to factor these, is to figure out what would be missing if I was trying to multiply times x plus 3 and end up with that trinomial. So this process always going to break down pretty much the same. We can write those trinomials of that form, x squared plus bx plus c, as the product of two binomials. So understand how. Let's do this as some regular multiplication. If I give you a question like x plus 3 times x plus 7, we could FOIL it, we could box it, we could use distribution. But either way, we get this answer as a trinomial, x squared plus 10x plus 21. So figure out where those parts are coming from for our steps. The coefficient of that x squared term, for now that's always just going to be a 1, so that's why we just have like a 1x squared. Coefficient of that x term 10 in the middle is the sum of those two numbers 3 and 7. So two numbers I started with, 3 and 7 when I started multiplying, combine those outside and inside terms, and we got 10x for our middle term. And 21 for our constant, we got that by multiplying 3 times 7, so that was the product of the two numbers we used originally. We're always going to see that pattern. And that pattern, again, if I start with my trinomial and I want to factor that down as two binomials, we need to figure out two numbers that have a sum of b, meaning your middle coefficient, and we need to also figure out numbers that are going to multiply to give us that constant. So how to multiply to get that 21. And looking at a couple examples of that very same process, let's take this and, again, try to figure out a factored form for this trinomial. So what I use is something I just call the x method. So this is really just a visual. What I'm looking for from this x method is I need two numbers that are going to add to give me 11 and multiply to give me 24. So I arrange the 11 on the top and the 24 on the bottom. And if I need two numbers that are going to work for that, we could get it right away, but we could just look and see from my factorization, if I was doing 1 times 24, that's going to multiply to get the correct constant. But if I added those, 1 plus 24, it's not going to add to get me 11. So if I use another pair of factors, something like 2 times 12 would get me 24 as well, but 2 plus 12 is not going to get me 11 either. So looking at our last couple pairs of factors, 3 times 8 and 4 times 6, again, these are all ways to multiply to give us 24, but only one of those correct ways is going to give us the right two factors. 3 times 8 gives us 24, adds to give us 11, so those are the two factors I need. Again, this is really just a visual way to organize and see which two numbers are missing. If I want to add to get 11 and multiply to get 24, those two numbers I'd be using are 3 and 8. So if I want to factor it, that's all I have to do. If I start off with r squared plus 11r plus 24, my factored form would use a 3 and an 8, and I can just write that as r plus 3, r plus 8. If I use foiling, box method, distribution, and multiply these back together, I would see that I would get right back to this trinomial. So trying that again with some other numbers, if I want two numbers that are going to add to give me 8 and multiply to give me 15, there's only two options. I could use 1 times 15 and multiply to get 15, or I could multiply 3 times 5. And we know that 3 times 5 is going to work because, again, I need to add to get that middle term. 1 plus 15 is going to give me 16, not the 8 that I need from that middle. So if I take 3 plus 5 and it gives me 8, 3 times 5 gives me 15. That means I can factor this down as x plus 3 and x plus 5. Really, the only step is to think of those two numbers. What's going to add to get your middle term and also multiply to get your last term. So let's imagine if I have different signs. If I have a negative coefficient of b and a positive constant, in this case, we're going to have to inspect negative factors in order to find our correct numbers. So for example, again, a negative coefficient of b is like a negative middle term, something like minus 6y, and a positive constant still ends with something like plus 8. So looking at this next question, I still arrange this using that same x method. I need two numbers that are going to add to get me negative 6 and also multiply to give me 8. So since if I multiply a negative times a negative, that will give me a positive. That's why it still works for a positive 8. But again, if I take negative 1 plus negative 8, it gives me negative 9. If I use negative 2 and negative 4 instead, those two add to get me negative 6, and those also multiply to get me 8. That means that's my factorization. Since I'm using y this time, y minus 2, y minus 4, we already have it solved. Trying that again with some other values. Again, notice this pattern is always if the middle term is negative and you have a positive constant. Only one way to do that is to multiply two negatives together. So -1, -24, that would multiply to give me 24, but not the right pair. -2 times -12 also doesn't add to give us -11. But if I use the correct pair of factors, -3 and -8, notice I didn't even have to list all of them. -4 and -6 would have worked too. But I know that -3 and -8, it's going to add to get to me -11. And it's also going to multiply to get me 24, so that's my factorization. Again, all this really comes down to is thinking of what two numbers are going to add to get your middle term and also multiply to get your constant. So let's imagine, can this work every time? If I do something like, well, I guess you guys probably already saw it, x squared minus x plus 2, not going to work because there's no numbers that are going to be able to get that result. If I'm trying to multiply to get a positive 2, I really can only do that with two negative numbers, -1 and -2. But since those wouldn't add up to -1, sometimes it just won't be possible. I can't pick two numbers that are going to multiply to get me 2 and also add to get me -1. If there's no pair of factors that'll work, we're just going to say it's not going to be factorable. So what happens if I have a different pairs of signs on these? Let's say if I have a negative constant, we'd have to find pairs of a positive and a negative in order to get the right factors. So that's different from the ones we saw before. Scrolling back up a bit, we had a positive constant on the last couple, just a negative in the middle, and at the very start we had a positive constant and also a positive term in the middle. So what happens if I get a question like this, and I get n squared plus 9n minus 36? So now that I have a negative constant, the only way I can multiply to get a negative is with one number positive and one number negative. So I still need those two numbers. I need to add to get the middle term and multiply to get our constant. So if I'm working through my factors, I know that one of my factors got to be negative, the other one got to be positive. That's how we get a negative multiplication. So I also know since my middle term is positive here, it's a positive 9. When I'm listing my factors, I know that bigger factor has got to be positive. Because if I add these, first row is just going to give me 35. That's not going to work. -2 plus 18, going to give me 16, so that's not going to work. But if I use the numbers -3 and 12, they add together to get me 9. That was my middle term. They multiply together to get me my constant. That was my -36. And notice again that bigger number was positive because our sign in the middle was also positive. So if I use that for my factorization, n minus 3, n plus 12, we already have the question solved. So just looking at a couple more examples, we could do this when the middle term is negative, unlike the last one. Just means in this case that when I'm picking my factors, since I still need to multiply and get a negative number, I'm just going to have to choose the bigger number to be negative and the smaller number to be positive. So if I use a 3 and a -7, that should work as my pair. They add to get me -4, multiply to get me -21, and since that -7 is larger, that's a negative like we needed for that middle term. So if I factor this, all I need is a c plus 3, c minus 7. So trying that last one, same steps, x squared plus 2x minus 15. I need to add my two numbers to get 2. I need to multiply them to get a -15. In order to do that, again, the bigger number is going to have to be positive. I want that positive 2. So if I choose the factors -3 times 5, that's going to work to get -15. 5 and -3 also ends up as a positive 2 once I add those together, so that's my factorization. X plus 5, x minus 3. Again, this x method really just a visual. We start with the top and the bottom. We fill in the sides once we know our factors. So trying an example in terms of a word problem, kind of like that very starting question. If they give us the rectangle's area and it's asking for both dimensions, not even giving us one here, we could figure this out just by using our same factoring method. Now we just need numbers that are going to add to get me -1 and also multiply to give me -72. We could start at the very beginning, again remembering that if the bigger number is negative, that's because we had a negative number in the middle. We could skip some pairs of factors if you already know the one that you should be using. A positive 8 and a -9 will add together to get you -1 and also multiply to give you -72. And a tip also is that if this number is not very big, like a -1, I know that my numbers are going to be pretty close together. So when I'm thinking of my two factors, -9 and 8, they're only a difference of 1 apart, so that's why I only have a -1 in the middle. I know my factors are close together since this isn't something like a 10 or a 12 in the middle. So again, if I'm looking for that factorization, x minus 9, x plus 8, those are my only factors I need. So what happens though if we get a little tougher question and we have more than one variable? So let's say if we had this kind of question. P plus 9q, P plus 7q. I could have given this to you in the last couple sections. Just again, got a FOIL, distributor, box method it. I use FOIL, so first, outside, inside, last. Combine those two inside terms, we already have our answer. But like we've seen in those other sections, that implies that we should be able to start with this trinomial and get it back into this form, factor it as two binomials. And we can do that as long as it follows the same kind of process. What we're always going to see here is that the first term has a square of one variable, that was p squared. The last term has a square of both, or sorry, the square of the last variable, that was q squared. And I kind of skipped this, but in the middle we had both. So we had p and q put together. So we can factor these following the same kind of step. Picking this example, again, if I need numbers that are going to add together to get me 6 and multiply to get me negative 27, since that negative is a constant, or sorry, last term is negative, we need to know a number that's negative and positive in order to get a negative result. So since that larger number should also be positive, I know if I use negative 1 and 27, not going to add together correctly. But if I use negative 3 and 9, those two add to get a positive 6, multiply to give me negative 27, those are the factors I need. And if I was filling this in my factored form, a last answer would just say something like m minus 3 and m plus 9. Now that I have two variables, though, we have the square of the first variable, square of the second variable, and in the middle we have both. It does follow my step. Only thing I got to do here is throw both variables into my answer. So instead of just saying m minus 3, if I have an n there as well, I can just say m minus 3n. And same thing with my second binomial. I can say m plus 9n, because I'm just using that 9 from my x method. So same kind of question, x squared plus 6xy minus 55y squared. Looks kind of intimidating, but I have a square of the first variable, square of the second variable, in the middle I have both. So my step is the same. I still want to think of two numbers. They're going to add to get me 6 and multiply to get me negative 55. Since that's a negative number to end with, I need a negative and a positive number. And I also need the positive number to be larger because that middle number was positive. So negative 1 times 55 would work, except it doesn't add to get me 6. Negative 5 times 11, that's going to get me negative 55. And also if I add those, again, it's going to get me a 6 as a result. So those are my two numbers. Again, the only thing I got to watch out for here, if I use x and y in the question, I just use x and y in my factorization. So x plus 11y, using that positive 11, x minus 5y, using that negative 5, and that's my factorization. Doesn't change much if I'm dealing with two variables, just got to make sure both of them are included in my answer.